So first up, we have a presentation from Kemal Sanjta, representing the BGP Clock and BGP Observatory hunting stuck routes. Kemal is a Principal Internet Analyst at Cisco ThousandEyes. This is Kemal's third presentation at NANOG. Thank you very much. And we're happy to welcome him back to the NANOG stage today. Welcome.
Hi. Thank you so much. Hello, everyone. It's great to be back at NANOG. My name is Kemal Sanjta. I'm Principal Engineer at Cisco ThousandEyes. And today, I'm going to speak to you about hunting stuck routes. More specifically, I'm going to speak about the BGP Clock, which is the method that we devised for tracking these stuck routes, and BGP Observatory, which is the tool that's going to help you identify whether you are affected or not. So, BGP Stuck Routes or so-called zombies is not something new. It's been happening for quite some time on the global internet, and it's the challenge that we spoke about historically on a couple of different forums, including NANOGs and RIPE events and stuff like that. But I'm going to reintroduce the problem briefly. Regardless whether we are dealing with the software or hardware solutions, they are prone to having bugs. Right? And regardless what's the purpose of that hardware or software, it's just going to have bugs, right? When it comes to routers, they are unfortunately not exempt from this problem, right? So when it comes to BGP implementation on the either software or hardware solutions, when it comes to vendors, we are dealing with the bug that results in update messages being lost, and as a result of which they don't get processed, and that leads to multiple different problems from the operational perspective. Obviously, update message is kind of important one in the BGP world, right? We are advertising new prefixes, we are updating path attributes using updates, and we are processing withdrawals using updates, right? And in this particular research, what we did is we double-clicked into the problem that arises as a result of withdrawals being not processed. So why is it a big deal? Well, ISNs are not informed that the path is no longer available, and obviously, from that perspective, this is a significant problem. So let's say that you are dealing with a problem as a result of which you have a congestion in your network and you want to do some traffic engineering to work around the problem. You do your traffic engineering to withdraw the path, and all of a sudden it's not withdrawn, and you are still receiving a whole lot of traffic on that particular congested path, which results in very bad customer experience. And from the experience as operators in this room, we know that we are going to be dealing with the packet loss, that we are going to be dealing with situations such as blackholing, and overall, end users and customers are going to have bad time. Also, one of the important aspects of this problem is the fact that this problem is not related to the other ASNs that are downstream or upstream, depends on the direction of which you are looking at the problem. What does that mean? Well, that means that usually from the operational perspective, traffic is going to get blackholed, because if you don't process that, downstream company is going to believe that you are dealing, that it's a legitimate path that still works, and they are going to keep on sending the traffic, and that traffic is going to get blackholed. And according to our research, this is not something that rarely happens on the internet. In fact, it's happening hundreds of times daily. So we wanted to actually see what is it that we can do about this problem, and whether we can identify something that's going to help mitigate this. There are a couple of different efforts currently ongoing to mitigate and ease this problem, namely RFC 9687, which is a send-hold timer, is being introduced exactly to tackle this problem. And while it's a step in the right direction, as we already know, it takes time to implement these features into vendor equipment and solutions. And on the other side, from what we were able to see, software-based implementations were faster to adopt this. But in general, like if you have a support contract with your vendor, regardless of whether it's like one of these big ones, including Cisco, utilize the contacts with the account managers and push for this implementation of this RFC, because this can help mitigate this problem significantly, or even make it, completely resolved problem. But also, this is a bug. At the end of the day, there are different theories on what is contributing to this particular problem, but we don't know for sure what's the root cause of it. So we wanted to perform internet scale research, and as it's usually the case, whenever you are doing something on large scale, you're going to have some challenges, and this research was not exempt from that either. So what did we do? We studied this manually and presented it at NANOG 87 and NANOG 93. And as part of that, every 15 minutes, we would advertise this IPv6/48. And after some time, we would withdraw the prefix. And then a couple of hours after that, we would observe what's happening from the global routing perspective, whether we are able to identify different autonomous systems that are still holding this previously withdrew prefix. So that was the methodology. And for this purpose, we utilized public BGP sources like TriPris, root views, and we were effectively checking what I just said, like who still holds the previously withdrawn prefix. Interestingly enough, we were able to identify autonomous systems that kept the withdrawn prefixes for months after they were supposed to be gone, which tells us that, routes are getting stuck. Even more frighteningly, actually, we saw that certain autonomous systems kept this prefix even once we made it RPKI invalid. So that did not make any kind of difference, which tells a lot about the RPKI validation status of today, effectively. Given the fact that we spoke about this previously at NANOG, RIPE, and similar forums, we got a lot of feedback. And one commonly asked question is like, what's with IPv4? Because previous study was IPv6 only, right? So that was a legitimate feedback, and we wanted to act on that. But also, some of the feedback that we got was related to long-term beaconing, right? So operators wanted to see what's happening with these prefixes from the perspective of their own RIBs. Researchers wanted to study this problem a little bit deeper to identify additional patterns and to figure out whether there's some more insight to this problem. And also, we wanted to just generate more data that's going to be publicly accessible for everyone using these public sources such as RIPE-RACE and root use projects. And the answer to all of these improvements, whether we can do them, is obviously yes. So the team of researchers, Cisco ThousandEyes, actually spent significant time working on this problem. And we devised this method that we called BGP Clock for identifying whether the autonomous system is holding stuck routes. Now, obviously, as the name implies, BGP Clock means that we encoded time within the BGP advertisements, which means that finally you can drop using NTP on your networking equipment. Let's push BGP for everything, right? Jokes aside, what's the BGP Clock? So effectively, we are still advertising /48, IPv6/48. And as you can see here on the third hextet, we have this value of n, which is the index of 10-minute period since the beginning of the year. So on January 1st at midnight, we are going to advertise this hextet, third hextet with the value of 4 zeros. And then 10 minutes later, we are going to increase the value to 1, and we are going to continue doing that over time. So you can actually see when was the advertisement originated. And this time around, to address the community feedback, we introduced the IPv4. Using the modulo of 8, based on the hour of the day in UTC, you can devise when was this originated. So in this particular case, at midnight UTC, we are advertising 216 as a third octet, but 1 hour later, we are advertising 217 and so on. So we encoded time within the BGP advertisement. If you want to find out latest and greatest documentation about this, it's available with this whois query for both v6 and v4 prefix. Now this is version controlled, and if you go to ftp.tribe.net, you're going to see history of this. Obviously, within the documentation, we are explaining how do we calculate and how do we encode the time within the advertisement, but also we are documenting all the communities that are advertised as part of this project. So if you want to do some research from your side, you are more than welcome to give a check to the documentation and figure out where you can actually extend this further. And -R on macOS whois command on macOS requires -R for the legacy reasons. So what's the process? How did we do this? Originally, when we started this research, we originated all of these BGP clock advertisements from the autonomous system 4601. With the intention to move it to dedicated autonomous system, and I'm happy to report that as of November last year, we actually did move this to a dedicated autonomous system. Now, I need to make a clear distinction here. This autonomous system is operated by one of our researchers, Antonis Charton, who is effectively administrator for this autonomous system for all the connectivity, IP address space, and stuff like that. So, for everyone in this room and who is listening to this talk, if you want to utilize this data from this autonomous system, you are more than welcome to. So it's completely independent from Cisco, ThousandEyes, or any other organization for that matter. So IPv6 advertisements are recycled yearly. So we have a capability to actually check on the longer scale of time for how long these prefixes were stuck in global BGP routing table. So given the fact that we have the track of time now, we can go back and check for how long they exist. And given the fact that we are advertising /21 for this purpose from v4 perspective, we are recycling every 8 hours. Now, from the research perspective, we identified that this was a good trade-off because after 4 hours after the advertisements, things kind of settle down, and you can see these negative effects of stuck routes quite clearly after that 4 hours point, actually. So when it comes to V6, we are advertising it at the top of the hour, and then withdrawing it 10 minutes after that. When it comes to possibility to extend this 8-hour recycling cycles for V4, there's obviously capability to summarize these /24s into /23s, then for some time advertise these, and then continue doing them down the line to 22s and stuff like that until you reach the /21, which is the holding IP address space for this particular effort. Now, but ultimately, solution would be to utilize more IPv4 address space. So if you have, unused block of IP addresses sitting somewhere unused, we are more than happy to help you take that out of your hands for this particular purpose. So how to check whether you are affected by this problem? So depending on different network operating systems that you might be running, such as BERT2, Rotunda, Cisco-related stuff, Junos, these are some of the commands, show commands that you can execute to check whether you have these stuck routes in your routing table. Now, importantly, what to expect when it comes to this. When it comes to IPv6, usually what we saw that you're going to observe are two different prefixes. One for the current 10-minute interval, and potentially for a brief period of time, you might see the other one from the previous one until it gets removed. But usually you expect to see up to 2 prefixes tops. When it comes to IPv4, given the fact that we are advertising them on 1-hour intervals, you're going to see 2 of them, one of them being for the current hour that you are advertising it for, but also the aggregate /21 that we are advertising for complete space. However, if you are dealing with the stuck route problem, it's very likely that you are going to see quite large number of these prefixes, sometimes even hundreds for V6. So what did we do? As you already know, there are a couple of different collector networks from the BGP perspective. One of popular ones being RIPE-RISC project, as part of which they are on certain schedule publishing RIB and update dumps, and same goes with the route use. From the Cisco ThousandEyes perspective, we operate the quite comprehensive network of BGP collectors all across the globe, both V4 and V6, which are near real time, and that gives us particularly good visibility for this kind of cases. So we were wondering, given the fact that there are so many different vantage points across all of these different collectors, whether we can utilize this enormously large data set to actually devise whether they are different stuck routes on the autonomous system paths across all of these different ASNs that are visible from these vantage points. And the answer was yes, we devised this solution that we call BGP Stuck Route Observatory. So what's that? That's a tool that can show you, it's a web-based tool, completely free, available to anyone with no login required that you can go to. You type in your autonomous system, and we are going to check, based on the algorithm that we devised, whether your autonomous system is affected by this problem. And there are a couple of different scenarios on how it works. So the first scenario, which is obviously the best scenario, is that you are not affected. So effectively, data that we are using from all of these different collectors is indicating that your autonomous system is not affected by stuck route problem. And we are figuring that out based on the fact that we haven't observed anyone who is holding BGP clock prefixes that you are advertising on your autonomous system path, or whether you are it's your downstream, upstream, or something like that. So this is a best case scenario. However, sometimes it's someone else's problem. So what happens is that you type in your autonomous system number, and based on the data that we have, we can actually identify that your autonomous system is affected by someone else's autonomous system. So be it your upstream provider or someone down the line, we notice that you are effectively a victim of someone that's holding the stuck routes. And that's, from the operational perspective, if you think about this, this is the biggest problem. Why? Well, because we have a limited tools to address these problems from the third-party perspective, right? Yes, you can try to do some traffic engineering, but there's, sometimes it does not scale. And given the fact that it's BGP in 2026, you're going to probably resort to people in this room to actually escalate the problem internally, or you're going to pick up the phone and call network operations center of that company who is holding your prefixes and try to make them aware that there's a problem, right? So not ideal solution, but it's what it is. And sometimes it's just you, right? Sometimes you can identify that your particular autonomous system is the one that's holding stuck routes that you are advertising as part of the BGP clock prefixes. Now, if you scan this QR code, you are going to get to BGP Stuck Route Observatory, and I promise you we are not going to rickroll you on this one. Okay, so as with any large-scale research or research on the large scale such as the internet, you're going to have some challenges. And this research was not exempt from that. So here, if you look at, and we categorize these challenges in three groups. One is visibility, the second one is invisibility, and the third one is intra-AES inconsistencies. And I'm going to briefly speak about all three of these. So if you look at this diagram here, what's happening here is that you can see autonomous system that's advertising BGP clock, and we are advertising that clock to all its peers. But if you look at the graph a little bit closer, you're going to see that only one customer of one of the peers has the BGP collector, be it a BGP collector from Ripe Risk Project, ThousandEyes, or root views. So this is a clear visibility problem. The node, customer node on the left-hand side won't be visible from our perspective when it comes to this research. So as of right now, we have visibility across 1,500 autonomous systems between the BGP data providers and the BGP clock origin. So 1,500 is not that bad. But if you take into consideration that it's just around 1% of overall number of available or total ASNs, that's kind of visibility-related problem. Good news in this one is the fact that within this data set that we have all the tier 1 networks, all the large enterprises and stuff like that. So it's not as bad as it seems, right, from the visibility perspective. Based on heuristical approach when it comes to this research, we can actually deduct more than 50% of ASNs using concept of cones, right? So case in point here, we saw that, for example, one of the large companies was affected by the stuck route in their own network, and we saw it from approximately 20 different data feeds, but that particular ASN cone contains more than 2,000 ASNs. So the question that becomes, are those other autonomous systems in their cone affected? Heuristically looking, it's safe to assume that they are, but it's hard to say for sure, right? Without means to log in and visibility in their networks, it's hard to say that they are. The second problem, or second category of the problem, is invisibility. And when it comes to invisibility, as you can see on the graph, we are making a case for the IXP root servers. Sometimes ASNs don't appear for a good reason, like it's for design, right? Sometimes, unfortunately, there are certain companies that are doing this on purpose so that they can shorten the autonomous system path, so that they look better when it comes to connectivity, but that's a bad practice. So what happens once the root server starts working with the stuck route? Well, we attribute the stuck route problem to all of its peers. So obviously, contribution problem is problematic. So let's say that they have 200 of them. Obviously, they are not going to have their own ASN in ASN path, and we are going to contribute the problem to all of them, right? Not ideal, but you know, given the fact that it's such a large-scale problem affecting multiple different ASNs, we can safely devise that it's an IXP related challenge. One of the interesting things that we saw is the fact that majority of these IXPs for the root servers are using the software-based implementations, and usually these software-based implementations are easier to upgrade and patch, as a result of which we don't commonly see that. We have seen the problem on some of the appliance-based IXPs, and they were affected. So it's not that everyone is 100% clear. Like we solved this problem. And the third large category of the problem is intra-AS inconsistencies. And obviously, if you think about it, autonomous system number obfuscates complete design of the network. And sometimes these networks can be few routers, but often there are thousands of routers. And we don't know anything about their internal structure, right? Just by the autonomous system itself. And that means that within your autonomous system, you can have hundreds of, if not thousands of routers that are patched, that are upgraded to the latest and greatest software, but one of them is misbehaving, or one of them is not upgraded in time, and it's exhibiting the problem. So it becomes really hard to actually pinpoint where the problem is, even if you have the login to the network itself. We try to actually use BGP communities to narrow down these problems with limited success. So given the fact that community is a well-known, optional, transitive attribute, you can play with it, you can do whatever it's that you want to do with it, but also one of the things that you can do is just ignore it as well. So relying purely on figuring out where the problem is based on the BGP communities. So for example, I can check whether this is advertised from this part of US or from Washington, for example, based on the communities. But different companies are going to have different communities for different things, so that's gonna have negative impacts, and it's really hard to automate any kind of investigation based on the community because of these inherent challenges of how they work. We found the cases where, for example, we found the cases where we observed the stuck route in one of the tier 1 providers, and only 5% of their peers were affected by the problem itself. So now it becomes investigation about like what is it that was happening in that part of their network that affected that particular 5% of their customers. And it turns out that, you know, it's usually based on the investigation of these communities, which is time consuming and stuff like that, that you find out that they are in either physical or virtual neighborhood, and they are affected by something that's happening within that part of the network. Also, root reflectors are quite interesting example. So if the root reflector is misbehaving and you are optimizing convergence using the reflector groups and stuff like that, only a subset of these reflected routes can be affected by this problem. So in general, like even if you have the logins and means to do something about this within your network, it's sometimes hard to actually identify where the problem is originating from. BMP, or BGP Monitoring Protocol, can help with this because it provides the ability to create a timeline of advertisements, so you can actually track that, and it can help you audit the problem from that side. But BMP still leaves, unfortunately, a lot to be desired when it comes to implementation and modern implementations from the vendors, be it from the perspective that some of the large-scale companies are afraid with instabilities of the software, or feature set is just missing for something that's needed by them, so they are kind of hesitant to deploy BMP. And so with that, I'm going to yield my time, but I'm more than welcome to hear some of your feedback. And if you have any questions, I would love to hear them. Thank you.
Okay, do we have any questions? Patrick.
Hi, Patrick, representing Tigger. Do you have any feeds? I see that you have feeds from different places. Do you you talked about like route reflectors and confederations and IBGP problems. Do you have any IBGP feeds? Has anybody given you, like, made you a route reflector client so you can see more of the internal from their network? I can't hear you.
Unfortunately, not for the publicly advertised stuff, but for internal customers, that's something that we could do.
Okay.
Anyone from the remote audience have any questions? No, no remote? Okay, great. Thank you again, Kemal. That was great.
Thank you so much.